We started this chapter, if you call it chapter, in 5.1 we started with solving quadratic equations, and we looked at ways to do that at the beginning. And in terms of doing that, we talked about when we have our factored form, we can set one of the factors equal to 0 and we can solve that way. What I want to do with this lesson is just sort of summarize all the different tools that we have so far for solving quadratic equations. So if we have the vertex form, in the vertex form, x appears only once. Okay, so x appears only once, and when that happens, when x appears only once, there we go, I got my pen working, we can isolate for x. We can undo the things around it and get x by itself. So we actually did this in our previous unit when we were solving some of our questions. So in example A, I have x appearing only once right there, so I can start undoing things around it. So I could subtract 75 from both sides. Subtract 75 from both sides, and we end up with minus 3x squared being equal to negative 75. And then to get x squared by itself, oh darn, having a little trouble writing tonight. So that's a negative 75 there. And then to get x by itself, we're going to divide both sides by negative 3. And then we get x squared being equal to 25. And then to get x by itself, we would undo the exponent 2 by square rooting both sides. And when we square root both sides, we get the plus or the minus answer of that square root of 25. So x equals positive 5 or x equals negative 5. Okay, so that's one option for solving that. Another possible option would be to use our factoring skills. So in this example, I've got the or here. I've repeated the question. I could common factor negative 3 out of both terms. So I get negative 3 times x squared minus 25. When I common factor that negative 3 out, that's equal to 0. And then I have a difference of squares inside the brackets. So I would have x take away 5 times x plus 5 equaling 0 equals 0. And so the only way that I can get an answer of 0 is if one of those two brackets is equal to 0, because negative 3 is just a negative 3. It will never equal 0. So that gives us two answers, either x minus 5 equals 0 or x plus 5 equals 0. And then if we undo the 5 or negative 5 from the x, we're going to get x being equal to 5 or x is equal to negative 5. Okay, so that's the same answer as what we got in the previous, just a different method of solving that one. So the reason I could do that with that is because this actually is also in its standard form. It's vertex form and standard form in this particular case. It just is because the bx term is a 0 for it. All right, looking at example B here, I want to get the x alone. There is x appearing only once in the entire equation, so I can start to get x by itself by undoing the things around it. So if you want to put this on pause and try it, go ahead, and then I will fill in the rest of the solution. Okay, so when I subtracted 98 from both sides, I got negative 2, x minus 4 squared equals negative 98. Divide both sides by negative 2, we've got x minus 4 all squared equals 49. Then I took the square root of both sides, and that gives me two things. So I've got x minus 4 equaling positive 7, or x minus 4 equals positive 7, or x minus 4 equals negative 7, which then gives me an answer of x equals 11, or x equals negative 3. So take some time right now, put this video away, put it on pause, put it away, try some questions here under your term, solve the following. Okay, make sure you understand how to isolate for x before you go on to the next part. And then you can take a look at solving from factored form, which is really just a review from 5.1 that we've already done. Okay, solving from factored form. We know that if we already have our factored form, the only way we can get an answer of 0 is if one of the two things that are being multiplied together here equals 0. So actually the negative 2 is a number. We can just ignore that, and we get either x equals 0 out of this, or x plus 8 equals 0, which then gives us x equals negative 8 as our second solution. So either x equals 0 or x equals negative 8 are our solutions here. For the second example, we've got 3x minus 7 multiplying 2x plus 9. The only way the answer will be equal to 0 is if either the 3x minus 7 is equal to 0 or the 2x plus 9 is equal to 0. All right, so then if I go ahead and solve my little mini equation, I've got to add 7 to both sides on this one, plus 7 on both sides. I get 3x equals 7. And then divide both sides by 3. And I get x being equal to 7/3 as one of my solutions. And again, if this was a parabola with a y equals, I'd be finding the x-intercepts. That's really the same thing if I look at the related quadratic function. All right, we get a 2x equals negative 9. Divide both sides by 2, and we get x equals negative 9 halves. So those are our solutions for that one. And then it's your turn again. Put this on pause, put it away, try the next examples. Make sure you understand how to do that before you go to the next part. Okay, from standard form, we have a few methods we can use from standard form to solve, to get the value of x that would make the equation true. The first one being, so the first way we can figure this out is by factoring. We factor the quadratic and solve as we would with the examples we just did above. So always, always, always look for that common factor first, and in part A I see a common factor of x. That's going to factor to be x times x take away 8. That equals 0. The only way I'd get a product of 0 is if x equals 0, or if x minus 8 equals 0. So this is why we were always talking about switching the signs to get the x-intercepts. It's actually an x-intercept at positive 8, but that's the reason why. The value of x that would actually make this equal to 0 would be positive 8. All right, the next one I'm going to try factoring by looking for two numbers that will add to negative 7 and multiply to positive 10. And I believe negative 2 and negative 5 will do that trick for us. And because it's a simple trinomial, we can slide right into the factored form. X minus 2 times x minus 5 equals 0. I've got an extra equal sign that I shouldn't have there. Let me erase that. All right, and then that tells me either x minus 2 equals 0, which means x equals 2, or x minus 5 equals 0, which means x equals 5. The next one, I'm going to rearrange everything so that I have it equaling 0, and I like to keep my leading coefficient to be a positive. So I want to keep my positive 2x squared. I have a plus x, and then it's equal to 3, so I would be really subtracting 3 from both sides here. And we get subtract 3 equals 0. This one's a tricky trinomial, and I really didn't leave enough space here, I don't think. I'm adding to 1 and multiplying to the products of the outside, so I'm multiplying to negative 6. I believe 2 and 3 multiply to 6, and I want a negative, so I'm going to make the 2 negative because negative 2 plus 3 adds to positive 1. So this is the one where we need to decompose or break down that middle term. So that plus x becomes a minus 2x plus 3x, and then we still have our minus 3 and equaling 0. I pair them up for common factors. The first pair has a 2x in common, leaving me with an x minus 1. The second pair has a plus 3 in common, leaving an x minus 1. That cooks it up so we have an x minus 1 in common to both, and then we have a 2x plus 3, and that has to equal 0. Oops. The only way that that can equal 0 is if, let me just change that to make it look like an equal sign. There we go. Is if either x minus 1 equals 0, which means x is equal to 1, or if 2x plus 3 equals 0, we would subtract 3 from both sides to get 2x equals negative 3. Divide both sides by 2, we get x equals negative 3 over 2. See, I didn't really leave enough room for those questions. I left too much room for part A and B and not enough for C and D. All right, try the same thing with this one. I want to get all my values on one side and having it equal to 0 on the other. So I bring that 25x over. I still have my plus 14 equals 0. I'm going to use some of this space up at the top here, up above. I'm looking for two numbers that would add to negative 25 and multiply to 16 times 4. That's 24. Carry the 2. That would be 84. Oh, minus 25 and an 84. I believe it's negative 4 and negative 21. 21 times 4 would be 84, yep, and they add to negative 25. Yep, that works. Okay, so then we decompose again. I'm going to put the 4 with the 6 and the minus 21x with the 14. You could do it the other way around. It will still work. In the end, you should still get the same two factors as what we'll get here. 2x is common for my first two. And then out of the second two, I believe I can take a minus 7. So we would have a 3x and a minus 2. And then minus 7 would have to multiply a 3x and a minus 2. So one of my factors is 3x minus 2. The other factor is 2x minus 7. And then each factor is set equal to 0 to solve for the x values that will make this equation true. So 3x equals 2. Divide both sides by 3. X equals 2/3. So I'm squeezing them. I'm kind of skipping a couple of steps here, but I'm saying them out loud. I'm going to add 7 to both sides, so I get 2x equals 7. Divide both sides by 2, I get x equaling, so x, oh goodness. Try that again. X would equal, this is not going well. Divide both sides by 2, we get x being equal to 7 halves. There we go. All right, so there's some more your turn questions to do, I believe, on the other side. So give those a try, and when you get those all finished, then you can go on to the next video.